So in this video, I'll be doing AKS 36 to 37 since they're basically the same thing. So AKS 36 to 37, graph rational functions, identifying zeros, and asymptotes when suitable, and factorization. Okay, so let's start with something simple. So y equals 1 over x, and let me draw my graph. Okay. So this function has a vertical asymptote at x equals 0. So our vertical asymptote would be x equals 0, which is on the y-axis. So this would be drawn right above here. Okay. Now it also has a horizontal asymptote of y equals 0. So a horizontal asymptote of y equals 0. This is on the x-axis. Okay, so with this function, the graph is placed on the upper right-hand corner and the lower left corner. So next we want to find our domain, and the domain represents the x values. To get the domain, you have to get rid of the vertical asymptotes, that's how you say it, and the x chord of any holes that you have. So the lowest x value right here is -0, and the highest is positive infinity. So the domain would look like this. And the union would look like this. Now for range, oh, this is our domain. Sorry. What did I put? This is our domain. Now for a range. For a range, we need to remove the horizontal asymptotes and the y values of any holes that we have. But we don't have any holes in this equation. So the lowest y value is -infinity, and the highest is infinity. See, right here, the lowest is -infinity, highest is positive infinity. So the range would look like this. So the range would be -infinity, 0, and the union would be union, same thing as domain, 0, and positive infinity. So remember that the domain lists off all the possible x values that the function can have, and the range represents the possible y values the function can have. Try another equation. So with this, we have y equals what that is. So first, let's find our vertical asymptote. I don't know how to say. So anyways, our vertical asymptote would be x minus 3, because even if it says x, when it says x minus 3 equals 0, that's the same thing as x equaling 3 for vertical asymptotes. Or, yeah, that's how you say it. Next, we want to find our horizontal asymptote. So notice that the degree of the numerator is the same as the denominator. So if we pay attention to the leading coefficients, and if we factor this, it would give us 2x minus 4, 1x minus 3. 2 divided by 1 would equal 2, so our horizontal asymptote would be y equals 2. All right. So by setting the numerator equal to 0, y is 0. And from there, you can get the x-intercept. So we can set this to x minus 2 equals 0, which would give us x equals 2. So we'll have the points 2, 0. Now let's plot it. So, okay, so we would have it to 3. Our x-intercept would be 3. So, yeah, that's bad. And our y-intercept would be 2. How would I plot that? Okay. So now let's plot 2, 0. So 2, 0. So I messed up right there. So from here on out, we can already see that our graph will look something like this. Right through. And this graph looks similar to 1 over x, but it's actually different. Okay. Next, we want to find our domain and range. So we're finding domain right now. So lowest x value, the domain's lowest x value is -infinity, and x cannot equal to 3, and the highest is infinity. So our domain would look something like this. So domain is -infinity, 3, union 3, -10. I mean, -infinity, my bad. Next, we want to find our range. So our lowest x value is -infinity with a horizontal asymptote at 2. Then it goes to +infinity. So our range would look something like this. -infinity to union to infinity. And that's our AKS.